We don't do that here.
Right, I know. But academia basically tends to work on kind of the next generation thing that industry does not realize is going to have a big impact on what they do in 5 to 10 years. So what is the difference between JEPA and LLMs or generative architecture? Generative architecture, you give it, you take a piece of data, let's say a sequence of words, of text, right? You corrupt it in some way by removing some words, for example, and then you train a neural net, big neural net, to predict the words that are missing. In the case of LLMs, or the GPT architecture in particular, there's a trick, which is that you don't actually need to corrupt the text. The architecture is such that it is causal, so to predict a particular word, because of the architecture, the system can only look at the words that are to the left of it. And so implicitly, when you train the system to just reconstruct the input sequence on its output, you implicitly train it to predict the next token. And it's very efficient, it's parallelizable and everything. Okay, so that's generative architecture. It works because the tokens are discrete, there's only a finite number of them, and you can train the system to produce a distribution of all possible tokens. Okay, that's how LLMs are done. And then you can use it to do autoregressive prediction, right? You have it predict the next token, shift that into the input, and now you can predict the second token, shift that in, etc. That's autoregressive prediction. Okay, now what I'm arguing for is you can't do this for video, because if you tokenize video, there's still going to be a lot of things that are just not predictable, details like, what everyone looks like here, that you just cannot predict. So the idea of JEPA is you take your video, but you encode it into a representation space where a lot of details are eliminated, and then this autoregressive prediction that we were previously doing in input space, now you're doing it in this representation space. Now the trick is, and the reason why it didn't pop up earlier, is that to train the encoder and the predictor simultaneously is very tricky. The reason being that it's very easy for the predictor to basically force the encoder to not do anything, to ignore the input and produce a constant output representation, and now the prediction problem becomes trivial, right? But it's not a good solution. And so you have to find ways to trick the system into carrying as much information about the input as possible in the representation, but at the same time, eliminating some of the details that are not predictable, right? So the system finds a trade-off between carrying as much information as possible about the input, but only the stuff that it can predict. And that's the basic concept of JEPA. It's not, in terms of architecture, there is the encoder, which is different from what you see in LLMs. And the trick is in finding good training algorithms, basically, or procedures or regularizers to get the thing to learn interesting representations. Now, it wasn't clear until fairly recently whether this type of joint embedding method to learn representations of natural data, like image and video, would ultimately be better than techniques that are trained to reconstruct at the pixel level. But at FAIR, we had basically an A/B comparison where a big group was working on a project called MAE, Masked Autoencoder.